Coming to the last type of extraction, that is extraction of less reactive metals. How are metals of less reactivity extracted? So metals at the bottom of the reactivity series are less reactive. So if you can recollect the reactivity series, we had arranged the metals in the decreasing order of reactivity, and those at the bottom were least reactive. Among these were gold, silver, platinum, copper, and mercury also. So these are found in free state. They are found in free state because they do not have tendency to react with any other element. And the most common being gold, silver, and platinum. We wear ornaments made out of gold and platinum because they do not react with water, oxygen, etc. So they are found in free state. But reserves of copper in free state are very few. But metals like copper and mercury, though they are less reactive, they are not found in free state on a large scale. So the reserves of copper in free state are very few. Mainly copper is found in the form of Cubris sulfide. So we are going to study the extraction of copper from Cubris sulfide. So copper is obtained from cuprous sulfide ore just by heating in air. So what are the reactions? Cuprous sulfide, and it is heated, so it combines with oxygen and it gives rise to cuprous oxide, that is Cu2O, along with the release of sulfur dioxide gas. Now here again we have converted the sulfide ore into the oxide ore, as we had done in calcination and roasting. So here again, in the next step, cuprous oxide further combines with the ore on heating, and it gives rise to pure copper and sulfur dioxide gas. So this is a two-step process in which we obtain the metal copper in the pure state. In the next slide, we are going to study how mercuric sulfide is going to be obtained in pure state, or mercury is going to be obtained in the pure state from its ore, which is called as cinnabar or mercuric sulfide, that is HGS. Now in this two reactions, we will quickly go through the balancing part here. Again, here you can see 2 oxygen, here we can see 3 oxygen. So we will start by balancing oxygen. Suppose you start with the smallest coefficient 2 here. So that makes oxygen 4 here. To balance oxygen 4 on this side, we write a 2 here. So 2 oxygen from here and 2 from here makes it 4. But writing a 2 here makes copper 4. To make copper 4, we write a coefficient 2 here. So copper is balanced, but sulfur is not balanced. 2 here, but only 1 here. So we write a coefficient 2 to balance sulfur. Now if you count oxygen, it becomes 6. 2 2s are 4 and plus 2 6. So at the last you change the coefficient from 2 to 3. So 3 2s are is 6. Balancing here we have 1 oxygen, here we have 2 oxygen. So starting with oxygen, we will write a 2 here. Copper becomes 4, 5 and 6. So total 6 copper. So this is how we balance the equations. Hope you have understood what is extraction of less reactive metals and how it is brought about. One more example, additional example, it's not there in your textbook. We are going to take it up, and how mercury is extracted in its pure state. We will study how extraction of mercury takes place. Mercury is extracted from cinnabar. Sulfide ore of mercury is called cinnabar. So here we have taken sulfide ore of mercury, that is HGS. This is sulfide ore, mercuric sulfide, and it is made to heat along with air, that is it is heated in air, and on heating it gives you mercuric oxide plus sulfur dioxide gas. So here also we are going to convert the sulfide ore into oxide ore. Now this oxide ore is then further heated in limited supply of air, and we are going to get mercury in the pure state and oxygen gas is removed. So this is a decomposition reaction, thermal decomposition reaction, but in limited supply of air it is being brought about. So these two reactions are not included in your textbook, but then we must know how extraction of mercury takes place and what is the sulfide ore of mercury called as, that is cinnabar. So with this we come to the end of the various extraction processes for highly reactive, moderately reactive and less reactive metals. So now what we are going to study is about the various methods of how we can prevent the corrosion of metals from occurring. Now that we have completed the extraction and we have got the metals in the pure state, it doesn't mean that the metals are in their purest form. There are some impurities which are still left in them, and the last step that is carried out is refining. So refining of metals is the last step in purification, and it is brought about by the method of electrolysis. We will not study it in detail because it's not a part of our syllabus, but electrolysis is the process through which we can obtain the metals in their purest form. So let's move on to the methods of preventing corrosion, rusting of various metals. Let us now begin with corrosion of metals. Corrosion is a slow process of decay and destruction of metals due to exposure to oxygen, water, that is moisture, acids, etc. So due to this, the metals form a layer over them, like iron develops a reddish colored layer of iron oxide. It's basically oxidation of metals. Metals react with oxygen and they form metal oxides, and this layer deposits over the metal. As in case of iron, we have seen that it lessens the life of iron. In other metals, it changes the taste and spoils the food if the metal is undergoing oxidation, and so on and so forth. So let us first see what are the various metals and how do they undergo corrosion. So rusting is first of them. Iron oxide is formed, that is Fe2O3, H2O. Copper reacts with atmospheric carbon dioxide to form copper carbonate. This is called patination of copper. So copper, after reacting with atmospheric carbon dioxide, forms a greenish colored coat over it, and this is poisonous, and this greenish colored coat is of copper carbonate, and that is poisonous. And if we are going to store any food item in it, particularly curd or milk, it gets spoiled. So that is patination. Silver articles become blackish due to reaction with hydrogen sulfide and forms a layer of black Ag2S. Silver articles, if they are exposed to air for a very long time, we find that they turn blackish in color. And that black color is on account of the reaction of the silver articles with hydrogen sulfide, that is H2S gas. And the layer of black colored Ag2S, that is silver sulfide, is formed on the silver articles, and that gives them a blackish colored look. So that is corrosion of silver. Oxidation of aluminium forms a layer of black aluminium oxide on it. So pressure pans and pressure cookers often turn blackish in color after constant use, and that is due to slow reaction of aluminium article with oxygen, and it forms a black colored layer of aluminium oxide. So what are the various ways in which we can prevent this corrosion or rusting from taking place? That's going to be a part of our next slide.